Hi, everyone. I'm Matt. I'm an architect, and I'm also a student at the University of Westminster in the MSc Architecture and Environmental Design. I'm going to present my thesis, which follows a collaborative project with Elson Moran. My topic is low embodied carbon ventilation system for healthy learning spaces and consists of a comparative analysis of system to provide fresh air in temperate climates. Before we start, I would like to highlight some context. As you know, net zero targets drive a holistic approach to the building assessment, and we see a shift from operational carbon to the life cycle embodied carbon. But the first gap is that MEP systems are still being overlooked, and we clearly need more information on HVAC components. It's also interesting to note that ventilation design is not binary. There is a large variety between active and passive system. Second gap is that passive system in school, in my case, are usually used for passive cooling in summer only, and not really to provide fresh air. Indeed, the heat loss from exhaust air and the lack of indoor air quality control are the two main barriers to implement passive strategies. That's why my case studies have heat recovery and CO2 sensor. The methodology was based on both fieldwork and base work. And the first point was a literature review to investigate the potential of passive and hybrid ventilation system in meeting indoor air quality targets. Second point was semi-structural interviews and site visits to identify the characteristic of passive and hybrid ventilation system and the implementation in the design process. And the third point was 3D modeling to assess the embodied carbon emission associated with passive and hybrid in comparison to an active one. Interviews were conducted with a design team of 5 recent schools around London and Paris, and 3 of them were selected for the carbon assessment, full passive, hybrid, and a full active system. It's interesting to know that school occupancy is really important. In temperate climates, schools are mainly occupied in the heating period, and this makes the use of the heat exchanger relevant. But passive strategies, much more than active one, are very dependent on their surroundings regarding the air quality or noise pollution, for example. This was one of the main learnings from stakeholders interviews. We also discussed the importance of user control, the collaboration in the design team, and the physical constraints of passive strategies in the design process. The 3 types of ventilation system are analyzed in detail. The passive system is mainly wind-driven, does not require generated energy, which is good, but is very localized with a supply at low level and exhaust at high level. The hybrid one is more predictable because there is an active fan that maintains the airflow rate even on windless day, but this fan limits the potential of the stack effects. The third system, the active system, is very homogeneous, but uses generated energy all year and therefore does not benefit from passive potential. A hypothetical building has been designed according to the BB103, and the ventilation system was sized with the same airflow rates. The carbon assessment also took into consideration the wasted floor area and the number of service risers for each system. The results of the life cycle embodied carbon assessment show that the active system has the highest carbon footprint over 60 years. The passive system emits 15% less, and the hybrid system emits 31% less. The discussion of these results need to take in consideration at least 3 points. First one, this assessment do not take into consideration the operational energy, and this need to be added to the hybrids and the active system. Second point, the lifespan of the unit has a significant impact on the results. This graph is according to guide M, but optimistic scenarios show a reduction of up to 43% for the hybrid system. And the third point, the assessment is based on existing data. The significant impact of the unit, which is assessed with CIPC TM65, shows that, suggests that EPDs used for other components have been underestimated by manufacturers. I would like to thank you, all the participants of this research, and thank you for your attention.
Thank you very much, Mathieu. Any question? Let me.
You show some return air on your things. Is there? I mean, have you looked at the problem of ventilation bringing after having COVID and all that? Does it having recirculated air increases the possibility of?
So my system, the system that I chose don't have recirculated air. This one, I don't know if you see this one have recirculated air, but the three I chose have heat plates, heat exchanger that do not cross. It's cross-flow plate heat exchanger, so the exhaust air do not mix with the fresh air, yeah, which is indeed really important for the indoor air quality.
Thank you.
I know that the TM65 is a relatively new methodology to assess the embodied carbon. So I was wondering if you found that this method is a step forward to, because I noticed one of your first hypotheses was that there was a lack of methodologies to actually assess embodied carbon in MEPs. So I was wondering your comments if you found that it was useful and easy to adopt for your studies, especially for the active systems and hybrid.
I think it's a really step forward, a really good step, because today when we assess MEPs, we are using like typical factors, but we are not looking in detail about every component and looking about their life cycle. So I think it's really interesting. What is interesting in TM65 is there is different methodology. There is a quick simplified method, let's say, which I used because obviously I couldn't have all the information from the manufacturer for each component. But no, I think it's really interesting and really important to use TM65. If I will answer also the question that you asked earlier, Rosa, about if I had to do something different, I think I will use TM65 for all the components. So it will take more time, but I think it will be really interesting to have a proper independent analysis, because when we rely on EPDs, unfortunately, EPDs are not really complete, and they are incomplete and difficult to compare also.
Okay, thank you very much, Mathieu.